Hello everyone. So this is our math, another one which is from application math from your last practice quiz. So let's discuss this math now. According to this math, if you look at the question said the question said on January 1st, 5 cells in a patient's liver become cancerous. The cancer has a growth factor of 3.2, which means that every week the total number of cancerous cells increases by the factor x of this. For example, if 50 cells have cancer one week, about 50 into 3.2 equals to this cell will be the next week. So, in fact, if you look at the setup of the question, first idea is there is some growth factor here, there is some initial value here, because in the first week or at the beginning these are the infected cell. Then we have some growth factor, which actually gives us some sense, like what type of question may come from this setup. First question is, which equation correctly models the number of cancerous cells and as a function of number of weeks, etc. So x is the number of weeks here. X is the number of weeks, and the n is the n will be our function. As you can see here, let me point out something. Um, you may remember our formula. Our formula for finding exponential function is what? Formula for finding exponential function is f(x) equals to exponential function. F(x) equals to c a to the power x. C a to the power x. This is the formula for finding. This is the main format, or our starting, as we discussed in our exponential function c a to the power x. C is what? C is the initial value. A is what? A is the growth factor. So in this question, initial value is 5. So that means we have to put here 5, and A is what? A is the growth factor. So in our question, growth factor is 3.2. So it will be into 3.2 to the power x. You can write like this, or you can give bracket this side, then 3.2 to the power x also, which is this one. As you can see, 5 into 3.2 to the power x. This x will be on 3.2. 3.2, because power is 3.2. X is what? X is the number of weeks. X is the number of weeks. So that's the x. This is the answer of first question. Second question is, how many cells will be cancerous 4 weeks later? Round your answer to the nearest whole numbers. That means like 1, 2, 3, this kind of thing. That means now what? X equal to what? X equal to 4. X equal to 4. In the same function that we found here, we will put 4 here and do the calculation. And if we do the calculation, 5 into 3.2 to the power 4, if we do, what we get? We get 524.288. See this. This is the calculation. 5 into then 3.2 to the power 4. 3.2 to the power 4. Answer is this. So as you can see, answer is this. Just in the calculator, if you put the value, answer will come. In place of x, if you put 4, 5 into 3.2 to the power 4, answer is this. And if you round it off, then 524 is the answer. Now you can say, sir, why you did not write the decimal? Why you did not write the decimal here in the answer? Because we said make it whole number. Make it whole number. That's why we cannot write the decimal again. Next question: how many weeks will it take for this 1 million cells to become cancerous? Round your answer to the two decimal places, like 1.23. So 1 million. This question is, how many weeks? How many weeks is needed? How many weeks is needed means what? What is their question now? The question is find out the value of x. Now the question is find out the value of x. So our n value, the value of n is given. We have to find out the value of x. Okay. So just this is the value. Then we start doing the calculation. First in the first part, this 1 million came from this 1 million. This is the value. This value is given. How many cells are infected, that is given now. We have to find out x equal to what? Number of weeks equal to what? That's why in the same question, it was n equal to 5 into 3.2 to the power x. Now we have to put n equal to this 1 million, because we have to now find out the value of x, because this how many cancerous cell is infected, that is given, that is the reason. Now you see this 5 is extra number, so if we divide this number by 5, 1 million divided by 5 means 200,000. So 200,000 is here. So from this 200,000, if we convert it from logarithm, from the exponent to logarithm, then it becomes like this. It becomes like this. Let's take it. So now we have. Okay, let me write it. Let me write the whole math. Let me do the whole math. So our function was n equal to 5 into 3.2 to the power x. Now we have to find out x, and this is the value of n. So n equal to n equal to 1, 0, 0, 0, 0, 0, 0 equals to, this is the value of n. And you may notice that this 5 is some extra number here. Actually, we can send this 5 to this side if we don't want to write it there. Actually, we can do it in the next line also, but who cares? Just send it to this side, because this is possible in the algebra. We can just avoid writing some extra line. So this divided by this equal to, if you divide it by 5, this 10 will become 2, then this 5, 0. So basically we can divide it. So 2, then 0, 0, 0, 0, 0 equals to what? 3.2 to the power x. Now we can convert this to logarithm, because now we do not know what power we have to give and get 3.2. 3.2 to the power what equal to this, we do not know. That's why we will multiply both side by log or ln. Here we multiplied both side by ln, but log is multiplied both side by log, but ln is also possible. We can multiply both side by ln also, which is also doable. What do you want me to do? Okay, let's do with ln here, or log. Both is same actually. Okay, let's do ln, because log is done here. Ln is we are doing ln. We are multiplying both side by ln. So if we multiply both side by ln, then we get this, and as you know, this is the power. So power will come to this side first, and then into, we will have ln 3.2. We will have ln 3.2, and just to avoid another extra line. In fact, as you know, this 3.2 will come to this side down to this number. So basically it will be like ln this number here, 2, 0, 0, 0, 0, 0, then divided by this number here. Down here it will come, so it will become ln 3.2. Let me do it here. Ln 2, 0, 0, 0, 0, 0 divided by ln 3.2 divided by ln 3.2. Answer is 10.4. Answer is 10.49. Answer is see. Now I think you can see. Answer is 10.49 or 10.5 also you can say, or 10.49. 49 is better. 10.49 is better. So x equal to 10.49. 10.49. Okay, so this is how we get the solution of this question. This is how we get the answer of this question. Okay, so next one, let's go to the next one. Now in this question we have two parts. One is like which change would have resulted in fewer cells being cancerous 12 weeks later, reducing the initial value of the cancer cells by 2 from 5 to 3, or reducing the growth factor by 0.2 from 3.2 to 3. In other words, which of these changes would have been more effective at slowing the disease after 12 weeks? So, in fact, what they are telling us here is in our main function, our main function was 5, then 3.2 to the power x. So what this question is telling us is, okay, one time do this change. Number one, do this change. Instead of 5, write here from 5 to 3. Then do the calculation. This is 12. This x equal to 12. X means 12 because after 12 weeks, so x means 12. And do the calculation. Whatever is here, write it. This is first change. In the second change, actually the calculation is done here. As you can see, this is the calculation. If you do 3 is here, 3.2 to the power 12. So the calculation is this. Then in the 2 number, second change is, instead of, okay, now 5 will remain 5, 5 will remain 5. Instead of this 3.2, now do it, keep 5. Instead of 3.2, now it is 3. And 12 is here. Then do the calculation. Where is value less? And which one is better? Tell us. That is the question. So you will see, this is above 3 million and this is above 2 million. So which one is less infection? Less infection is here. Less infection is here. Okay, less infection is here. As less infection is here, so we can say that reducing the number of reducing the growth factor by 0.2 will give us like fewer or less infection. Okay, so reducing the growth factor is better. Reducing the growth factor is better. So this is the answer of this question. Reducing the growth factor is better, because if we reduce the growth factor in this case according to this value by 0.2, then we get the fewer infectious disease, infectious cancer cell. So we get it like this. So this is how we solve it. This is how we penetrate this this practical scenario, this practical problem. One time we have to change the initial value, another time we have to change the growth factor. When we change the initial value, do not change the growth factor at that time. When you change the growth factor, do not change the initial value at that time. Okay. All right. Another math we will discuss in another video, so that those only who have the problems in the next one, they can just view the next one. All right. Bye bye. Okay. So I have to first I can do this.